In the last video, we made a toy car with 2 DC motors. In this video, we will add switches to our car to make our car go forward, reverse, turn left or right, and control its speed. Have a look at the demo of what we will make. The toy car goes forward. Flip a switch and the car goes in reverse. Control the speed of the car. By lowering the speed of one motor, you can make the car turn. You can reverse and turn the car at the same time. And then, just have fun. Let's start in Tinkercad, where we will build on the circuit we had made in an earlier video. First, let's rename this project. Go to the top left and click the name Tinkercad has automatically assigned to this project. Then, type a name that describes the project. Say, Toy Car Circuit. In an earlier video, we saw how by flipping the polarity of a DC motor, we can make it rotate clockwise or counterclockwise. The motor where we have not changed the polarity is running at positive 172 RPM. And the motor where we flipped the polarity, that one is running at negative 172 RPM. Instead of flipping the wires manually, let's use a switch to make the motor rotate clockwise and counterclockwise. Delete the old wires. Search for a switch and drag out a slide switch. To flip the polarity, we need what is called a DPDT, or double pole double throw switch. A DPDT switch has 6 terminals. We don't have a DPDT switch in Tinkercad. So we will have to use 2 SPST, or single pole single throw switches. That is, 2 switches with 3 terminals each, so that we get 6 terminals. To flip the polarity, you have to connect the 2 corner terminals of these 2 SPST switches. Then connect the negative terminal of the battery to one of the corner terminals of the combined switch. Connect the positive terminal of the battery to the other corner terminal on the same side of the switch. Connect one of the common terminals of the switch to one terminal of the motor. Connect the second common terminal of the switch to the other terminal of the motor. Run the simulation. When both the switches are on the same side, the motor rotates at positive 187 RPM. When both the switches are moved to the other side, the motor starts rotating at negative 187 RPM. In this way, we can make a DC motor go clockwise and counterclockwise simply by using a switch. Remember, if you have a DPDT switch, the connections will be the same, but you will need to slide only one switch. However, if you are using 2 SPST switches, as we are doing now, you will need to slide both switches to the same side. In an SPST circuit, if one switch is on one side and the other switch is on the other side, the motor will not run. Actually, this is a good way to stop the motor running. It's like you have an on-off switch. Next, let's connect the second DC motor, because, in our toy car, we have 2 DC motors. We will connect the 2 terminals of the second DC motor to the middle 2 common terminals of the switch, same terminals where we connected the first DC motor. We can change the color of the wires to show which 2 wires belong to which motor. Start the simulation. When the 2 switches are on one side, both motors are running at positive 172 RPM. When we slide both switches to the other side, both motors start running at negative 172 RPM. This is how, using 1 DPDT, or 2 SPST switches, we can make our toy car go forward and reverse. Next, let's understand how we can control the speed of our motors. For this, we will need to add a potentiometer to our circuit. A potentiometer is a special type of switch. A simple on-off switch can either let all the electrons pass or none of the electrons pass. But, with a potentiometer, we can control how many electrons can flow in our circuit. You have seen a potentiometer. It is used in fans to control the speed of the fan. To make the name short, a potentiometer is called a pot. Disconnect one of the wires connecting the motor to the switch. Connect this terminal of the motor to one of the side terminals of the pot. Here, we are connecting the wire to terminal 2 of the pot. Connect the middle terminal of the pot, which is called a wiper, to the common terminal of the switch. Now that we have a pot connected to the motor, let's run the simulation. Motor 1 is running at negative 187 RPM, but motor 2, where we connected a pot, is not running. Let's turn the knob on the pot. When we turn the knob all the way, the motor starts rotating at negative 169 RPM. However, as you can see, we have very little control over the speed of the motor. The pot is mostly not operational and only works when the knob is turned almost all the way. To fix this, click on the pot. Its property panel opens up. Right now the resistance of the pot is 250 kilo-ohm. Resistance in a circuit is like an obstacle that slows the flow of electrons. 250 kilo-ohms is a lot of resistance. You can think of it as 250 kilograms of obstacles. Let's lower this to 250 ohms, which would be like 250 grams of obstacles. Now the pot is giving us a lot more control over the speed of the motor. When you build a physical toy car, you will have to choose a potentiometer with the right resistance. Let's duplicate this pot. Use the copy and paste buttons on the top left. Place the second pot close to the second motor and hit the R key to rotate it. Delete one of the wires connecting this motor to the switch. Connect this terminal of the motor to one of the corner terminals of the pot. Connect the middle terminal of the pot, the wiper, to the common terminal of the switch. Since this pot is a copy of the earlier pot, its resistance is 250 ohms, which is what we want. Run the simulation. You can control the speed of this motor using the second pot. So, now, you can control the speed of both motors using the two pots. Plus, you can change the direction of rotation of the motors using the switch. This is how you can make your toy car go forward and reverse using a switch. And you can control the speed of the car using the pots. With control over the speed of individual motors, you can make the car turn left or right. If the right motor is rotating fast and the left motor is rotating slowly, the car will turn to the left. Likewise, if the left motor is rotating fast and the right motor is rotating slowly, the car will turn to the right. If one motor is rotating fast and the second motor is not running at all, the car will turn 360 degrees, that is, the car will go around in a circle. How many degrees the car turns left or right can be controlled by changing the respective speeds of the two motors. This is how you can make a toy car go forward, reverse, change its speed, and make it turn left or right. Now that you understand the circuit, you can put a physical toy car together easily. Here is the circuit diagram. Have fun making this project.